This video is about exponential functions. Exponential functions have an equation that looks like this, f of x equals, and in general, we could say a times b to the x power. We know it's an exponential function when we look at the equation because the variable is in the exponent. A here represents the number that we are going to start with, and b here represents the multiplier. If that multiplier is greater than 1, we are going to have a increase. And if that multiplier is between 0 and 1, then we're going to have a decreasing exponential function. The multiplier here would never be 1 and would never be negative. Now, this number here, the start, we can see right here as the first point in our table. When x is 0, that's where we start at. Then the output is 3. It's also the y-intercept on our graph, the coordinate 0, 3. The multiplier here is the base, so it's the base to the exponent. We can see it in the table because it's the number the factor that this is going up by. In an exponential function, this factor is always the same number, but it is multiplying the values instead of adding, as we might see in a linear function. It's a little harder to see that on the graph, but if you look at the y coordinates, similar to as you did in the table, you can see that the y values are multiplying as your x values increase by 1. Other important features on a graph of an exponential is that it starts by increasing slowly and then it moves up more quickly. It also has what we call an asymptote. An asymptote is a value that the graph will continue to always be moving closer to but never reach. If you look at the y coordinates, as I drag this point to the left, the y coordinate is always getting smaller. It's getting closer and closer and closer to 0. And eventually Desmos might run out of decimal places, but it will never truly reach 0. It will always get infinitely closer. We can always put one more decimal place and get one more number closer to 0.